So all these are different types of errors that are handled by operating systems. What is the difference between multi-user environment and multitasking environment? After getting certain updations, U3 must be allowed to access the updated information. The system call refers to the call which is made by the operating system. Hello everyone, it is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's session, you will learn about the error correction or error handling in operating systems. How does the operating system handles the errors at the time of execution of any of the programs when it becomes a process? That is a topic of our interest in today's session. Now, files errors can be occur anytime. That is, the error can occur anytime and anywhere in the operating system or within the system. An error may occur in CPU, in IO devices, or in the memory operations, or in hardware. But in all these cases, the major activities of an operating system with respect to error handling involves. That means error handling is done by operating system. Which are the types of errors? CPU error, then which is the next type of error? That is memory handling error. And we have the hardware error, IO devices error. So all these are different types of errors that are handled by operating systems. So operating system constantly checks for possible errors. That is, the operating system takes an appropriate action to ensure correct and consistent computing with respect to CPU. This is with respect to CPU. Similarly, if I take up that in case of multi-user environment or multitasking environment, what is the difference between multi-user environment and multitasking environment is in case of multitasking environment, let me explain multitasking. I have job 1, job 2, job 3. So multiple tasks are done here. That means all these jobs are transformed into one of the user. That is job 1, job 2, job 3, then job 1 of user 1, job 2 of user 2, job 3 of user 3. That is user 1, user 2, user 3. So we have multiple users. So each of these jobs are done by one of the user. Each of these jobs are done by another user. Each of these jobs are done by another user. So we have multiple users with multitasking. But in this case, we have only multiple tasks are done by single processor. But in case of this, multiple users are used to do that multiple jobs or multiple tasks at the same time. This is called as quad core processors or dual core processors are available for this computation. If that is the case, we have a CPU cycles and file storage are to be allocated to each user or job. Following are the major activities. Which are those activities? In case of resource management, that is, the OS manages all kinds of resources using schedulers, whether it is a long-term scheduler or a short-term scheduler. It does not matter anything. Whether it is a long-term scheduler or short-term scheduler, all these are called as, all these are going to manage the resources. Then CPU scheduling algorithms are used for better utilization of CPU. That means CPU scheduling algorithms include first come first serve scheduling algorithm, which is the next type of scheduling algorithm we have, that is priority scheduling algorithm, which is the next type of algorithm we have, preemptive shortest job first scheduling algorithm, then non-preemptive shortest job first scheduling algorithm, then we have round robin CPU scheduling algorithm. All these are different types of scheduling algorithm that has got some certain criterias which needs to be met in each and everything while utilizing the CPU. That is the task of the operating system. If that is the case, if I move on to the protection, as I have already discussed with you in the previous session, that is protection of resources is handled by the operating system. That is computer system having multiple users and concurrent execution of multiple processes. That is parallel execution of multiple processes. Are done by whom? Operating system, within computer system. Then the various processes must be protected from each other's activities. Suppose if one of the program is being executed, user 1 wants to use this, user 2 wants to use this, user 3 wants to use this. So if there is any updated information, the updated information must be fetched by V2. Use U2. Then again, after getting certain updations, U3 must be allowed to access the updated information, not the old information. In order to get this, we have to protect the programs. So protection is necessary. So protection is necessary for resources. Necessary for resources. Then protection refers to a mechanism or a way to control the access of programs or processes or users to the resources defined by the computer system. That is, here you can see that the users are there, program becomes a process, processes are there, all these are controlled. All these are controlled by the computer system, which is that operating system. So if that is the case, moving on to the same protection, the operating system with respect to protection, OS ensures that all access to system resources are controlled. That is, it is controlled. The programs, when it becomes a process, it is controlled by operating system in terms of protecting it from other users. That is the point to be noticed here. The operating system ensures that external I/O devices are protected from invalid access attempts. Invalid access attempts indicates that, suppose if the transaction is successful, we say that it is in 1. It is unsuccessful, we say that it is 0. That means invalid attempts, external I/O devices may be a printer, printer spooler, or any of the devices like scanner. Scanner comes under the I/O devices. So all these are considered here, that ensures the protection from invalid access attempts. Then OS provides authentication features for each user by means of passwords. That means, suppose if there are multiple users, that is user 1, user 2 and administrator. Each of these users are given a specific password are given with specific passwords. So these passwords enables the users to log into the system, so that the protection is given to this user barrier is provided to this user and protection is provided to this user. So this is how the protection is provided among multiple users. Moving on to the accounting information, we have the operating system keeps track of the total number of accounts that are responsible for resources allocation and resource fetching operations. In multitasking, accounting enhances the system performance with the allocation of resources to each of the processes, ensuring the satisfaction to each process. What does the mean of this? In case of multitasking environment, as I have already discussed with you, in case of this multitasking environment, we are having this enhances the accounting information. What is the meaning of accounting information? Suppose user 1 is having certain password 1, then user 2 is having certain password 2, then user 3 is having certain password 3, then admin is having some admin password, that is admin password. So all these are certain information that needs to be accounted, which is done by, that is username password, username password, username password, username password. All these information of accounts information are maintained by the operating system. So that is how we are going to convince you in this manner. So we have a system calls next. When we have a system calls, which are the different types of system calls, that will be explained in the next session. But let me tell you, give you the information, what is the meaning of system call. Within a kernel, we have kernel level and user level. In case of this user level, user requests the operating system to perform certain operations. The operating system raises a request to the hardware devices so that the hardware devices interact with the system calls and in turn gives information to the user calls. So if that is the case, what is the meaning of system call? As I told you that the system call refers to the call which is made by the operating system. Then user first starts with the system call, then the system in the user mode, see here, system in the user mode. System in the user mode, when the request for a service, then the user mode will be converted into the kernel mode. Please see to it here, into the kernel level, which just listens the requests of the user and processes the request and display the results that are produced after the processing. That is, once when the request is processed, the hardware devices interacts with the system kernel, that is the kernel level system calls. The kernel level system call in turns gives information to the user level system. So this is how the informations are conveyed between user level and the system level. If that is the case, when user requests for opening any folder, or when he moves his mouse or mouse on the screen, then it is called as a system call. That is called as a system call, which is using for performing operations. That means when a mouse is taken over this, when a mouse is taken over this is called left, this right. Now when the mouse is taken over this, what is the cursor? The cursor is moving its point from one place to another place for opening the folder or maybe for any of the operations. That is called as one of the system calls. As soon as you move your cursor, the system call generates from user level to system level, so that the hardware devices connected to the computer will be able to move the control from one place to another place. This is how you are going to do the operations of system call. With this, I am going to conclude this session. Thank you very much. Thank you, one and all. Kindly come back to the college if you have any questions with respect to the topics I have discussed in today's session. And of course, many of the students are approaching me to learn the concepts even in more detailed information. So even if you have any questions, kindly come back to me. I will definitely be in the department. I'll solve all of your questions. Thank you very much. Thank you, one and all.